Okay, so now we're going to move into 6.2 where we take and actually apply what we learned in 6.1. So 6.1 was just telling you how the standard distribution, normal distribution works with your z-scores, and now we're going to do it with actual problems. So there's only one extra step compared to what you did yesterday. So instead of me telling you what the z-score is and whether you want to be above or below or in between two different z-scores, you're going to have to calculate the z-score first. Again, the z-score tells you how many standard deviations away a certain value is from the mean. Again, always in relation to what the actual standard deviation is. So, if I can get my pencil to work. There we go. This is the formula that you're going to use all the time for these. X minus mu over sigma. And again, we did this in 6.1. But it's very important that you make sure X is the given data value that they're asking about. Mu is the mean they give you. Sigma is your standard deviation. That again, these are populations. We're just assuming these are populations. Okay, so here's why we can do this. We're going to transform the scores. We kind of did this in 6.1. We're going to have a mean of 100 and a standard deviation of 15. All right, so what I'm going to do is I'm going to draw another line down here. And those are going to be my x values, the actual values according to this. So my mean is 100 and my standard deviation is 15. Okay, so if I wanted to just graph a number line that had my mean in the middle and counted by standard deviations, that's what it would look like, the x-axis. But again, what we can do with the standard normal distribution is we take and we change all of them to z-scores. So this is going to be my z number line. The mean is always 0, remember, and the standard deviation is 1. So 1, 2, 3, -1, -2, -3. So 115 has a z-score of 1 because it's one standard deviation above the mean. 70 would have a z-score of -2 because it's two standard deviations below the mean. And again, what's so cool about this is I could change this to anything. We did it in 6.1. I used a standard deviation of 5, I think, instead of 15. Or again, I could have a mean of 10 and a standard deviation of 2. So even though you can change the x values, your z values are going to stay the same. Okay? Again, this only works if you have a normally distributed data set. So again, that's where your highest is in the middle, and then it's basically symmetric on each side. All right, so this is what your questions are going to look like now from 6.2. Find the percentage of students that scored below 120. So 120 is not on our number line here, and you're not going to draw this out every time anyway. So the first step you're going to do for these is C equals 120 minus 100 all over 15. Okay, so again, number they ask you about is your x value minus your mean divided by your standard deviation. You can put that all in your calculator at once. Just make sure you put parentheses around the top if you're going to do that. All right, we're always going to round to 2 decimal places because if you remember from our z-chart, that big chart that you need to print off, your z-scores go to 2 decimal places. So 120 gives you a z-score of 1.33. So when we draw this out, and again, this is going to be up to you whether you want to draw it or not. That's going to have a z-score of 0. 1.33 will be over here. We want to be below it. So this is exactly what you were doing in 6.1. So you're going to look at your z-chart. And notice this picture looks like the picture we just drew. Whenever you look up a number in this z-chart, it always gives you the area to the left, okay, or the percent to the left. So when you look up 1.33, you're going to get 90.82. So because it said that this distribution was normal, that means 90.82% of the students scored above or below 120. And again, it makes sense that that's over 50% because 120 is well over the mean. Okay. Next one, we want to be above 95. So again, the only extra step compared to what you did in 6.1 is you have to calculate your z-score first. So z is going to equal 95 minus 100 over 15, and that gives you -0.33. Okay, so again, then it looks exactly like what you did in 6.1. So again, if you want to put the 0 in there, you can. You don't have to. Negative 0.33 is going to go here. We want to be above it, though. So this is where you have kind of the long way and the short way to do this. The long way is to look up negative 0.33, but remember that gives you the amount to the left. So if you do that, that's absolutely fine. You're going to get 3707. So then again, you need to do 1 minus 0.3707, and your final answer is 62.93%. Okay, the fast way to do it is if you just look up positive 0.33, you're going to get your 62.93 right away. Because again, the area to the right of a negative is the same as the area to the left of a positive because it's symmetric. Okay, that's the only difference between what you did in 6.1 and what you're going to do in 6.2. So these are just some practice ones. Each month, an American household generates an average of 28 pounds of newspaper for garbage or recycling. Assume the standard deviation is 2. And we're going to select at random and find the probability that it's generating between 27 and 31 pounds per month. So here you have to actually calculate two different z-scores. So you're going to do z equals 27 minus 28 all over 2. That gives you negative 0.5. And then you're going to have to do 31 minus 28 all over 2, which gives you 1.5. Okay, so again, you have to calculate two separate z-scores if they ask you for the amount between. And then we're going to draw it out. So negative 0.5 and positive 1.5. We want the area, or the percent, between. So again, you just look up both of these. Negative 0.5 is going to give us 3085. When you look up 1.5, that gives you 9332. And to get our final answer, then we just need to subtract them. So 9332 minus 3085 gives you your final answer of 62.47%. Okay, so every time you have an in-between, you're going to look up both z-scores and always take your higher z-score minus your lower z-score. All right, last one, more than 30.2. So again, the first thing you're going to do for these is figure out what your z-score, 30.2 minus 28 all over 2, and you get 1.1. So you're going to draw it out, or again, if you feel like you don't have to draw it out, that's fine. 1.1, and we want to be above that. So again, just like the one above it there, you have two options, the long way and the short way. The long way is to look up 1.1, and that will give you 8643. Again, if that's your final answer, you should ask yourself, does that make sense? Does it make sense that 86% of the people are going to have more than 30.2? That doesn't make sense because 30.2 is over your mean. Okay, so again, just kind of thinking whether or not that makes sense. So 1 minus 0.8643 is 13.57. Again, the shortcut way would have been to look up negative 1.1, and you have gotten your 13.57 right away. Okay, I'm actually going to stop this video just because it's easier to upload shorter ones, and then I'll do a second one for the back page.